There are some Carolina bays 11 miles west of Wichita, Kansas. They are found on the sandy deposits of the Arkansas River Basin, and most of them are severely eroded. Welcome to another edition of the Carolina Bay of the Day, where we study the secondary impacts made by the glacier ice boulders that were ejected by an extraterrestrial impact on the Laramide ice sheet. There is a link to the LiDAR visualization tool for Google Earth by Michael Davies in the description of the video. The colorful stripe in this image represents the topography of the floodplain of the Arkansas River. Wichita, Kansas is at about 400 meters above sea level. Each repetition of a color represents a change in elevation of 10 meters, so by counting the red stripes, for example, we can see that the elevation at the top of the image is 50 meters higher than in Wichita. Wichita is located along the Arkansas River, which originates high in the Rocky Mountains in Colorado. The Arkansas River Basin discharges water from several states toward the Mississippi River. Dodge City, which was a frontier settlement of the Old West, is located about 166 miles upriver from Wichita. During the mid-Cretaceous period, the western part of Kansas was under the Western Interior Seaway. This inland sea developed when the Arctic Ocean transgressed over western North America. The sea divided the continent into Laramide on the west and Appalachia in the east. A period of mountain building during the late Cretaceous, called the Laramide orogeny, 70 to 80 million years ago, created the Rocky Mountains. The increased elevation of the land caused the Western Interior Seaway to drain toward the Gulf of Mexico approximately 55 million years ago. For those of you who are new to this YouTube channel, the Glacier Ice Impact hypothesis, published in 2017, proposes that an extraterrestrial impact on the Laurentide ice sheet by the Great Lakes ejected pieces of ice in ballistic trajectories. The secondary impacts of the glacier ice boulders produced inclined conical cavities with raised rims that were transformed into shallow elliptical bays by viscous relaxation. The elliptical geometry has been verified for the Nebraska rainwater basins and for the Carolina bays in the Atlantic coastal plain. We will now verify that the impact structures in Kansas are also elliptical. We will examine 3 Carolina bays that are found about 11 miles or 17.8 kilometers west of Wichita, Kansas. The terrain in Kansas is very rough, and only a few places retain remnants of the inclined conical cavities made by the impacts of glacier ice boulders 12,900 years ago. Wichita Bay Number 1 is large. It has a width of 1,339 meters and a length of 1,829 meters. The bay has been heavily eroded by water flow and by soil movement. Water flows into this bay from the west and from the north, and it drains toward the east. The southern rim of the bay has moved southward toward the drainage channel, and the bay is too distorted for trying to fit an ellipse. A satellite view of the same area does not show any details of the bay. The red placed marker is where the rim of the bay is crossed by a dirt road for which there is a street view. The street view where the road crosses the rim of the bay does not show anything remarkable. There are just farm fields on either side of the road, but no raised terrain for the rim of the bay. Wichita Bay Number 2 is also highly eroded. The bay has a width of 1,102 meters and a length of 1,773 meters. Although the north rim has been completely eroded, the rest of the rim is preserved well enough for fitting an ellipse. The ellipse has a good fit along the south and east parts of the rim. The western part of the rim does not have a sharp edge, but the topography is still adequate for fitting the ellipse. The width-to-length ratio corresponds to an impact angle of 38.4 degrees. A satellite view of the same area shows only some agricultural fields and a residential neighborhood on the top right of the image. Placing the ellipse corresponding to the bay on the satellite map does not reveal any additional details about the bay. The street view across the east side of the rim does not show any remarkable features. It is only through the LiDAR images that we can detect the existence of these elliptical bays. Wichita Bay Number 3 is smaller than the previous 2, but it is better preserved because it is located on flatter terrain. The LiDAR image shows well-defined raised rims, except over the west. Mathematically, only 5 points are required to fit an ellipse to an elliptical curve, so it is not difficult to overlay this bay with an ellipse. The bay has a width of 620 meters and a length of 1,130 meters. The width-to-length ratio corresponds to an impact at an angle of 33.3 degrees. As with the previous base in Kansas, the satellite image does not reveal more information about the bay. We can only see the circles of pivot irrigation systems in the farm fields, but no evidence of the bay. Placing an ellipse on the location of the bay does not reveal any additional details. Wichita Bay Number 3 is located 1,353 kilometers from Saginaw Bay, which is assumed to be the point from which the ice boulder that made the bay was launched. The diameter of the glacier ice projectile that made the bay is estimated to be 226 meters, which is 1/5 of the bay length. The ballistic equations indicate that the glacier ice boulder that made this bay was launched at a speed of 3.803 kilometers per second. It had a flight time of 7.09 minutes and reached a height of 222 kilometers above the surface of the Earth. The trajectory was a suborbital spaceflight in the vacuum of space. The kinetic energy of the impact that made Wichita Bay Number 3 was equivalent to 9.58 megatons of TNT, which would have caused seismic vibrations of magnitude 8.14. The surface of Kansas should be completely covered with Carolina bays from the ballistic deposition of the icy ejecta, but the terrain is very uneven and the fragile elliptical sandy structures have not been able to withstand the effect of water erosion for 12,900 years. The Carolina bays must meet the following criteria. They have to have elliptical geometry because they originated as inclined conical cavities. They must have raised rims because they are the result of impact cratering, which forms the rims by compressive horizontal forces as the projectile penetrates the target. They must have a major axis oriented toward the Great Lakes because that is the location from where the glacier ice boulders were launched, and they must be within 1,500 kilometers from the Great Lakes, which was the range of the ejecta curtain of the extraterrestrial impact. The bays in Kansas meet all these criteria and add support for the glacier ice impact hypothesis. Thank you for joining me in the investigation of the Carolina bays and the Younger Dryas cataclysm. I will continue to examine the Carolina bays one bay at a time. My book about the Carolina bays is available at Amazon. Please subscribe to my YouTube channel to be notified of future videos about the Carolina bays.